The origin of the universe is still a question that plagues scientists. Extensive research has revealed the influence gravity and energy holds over the development and life cycles of galaxies, including our own Milky Way galaxy, stars, and planetary systems. The Nebular Theory states that our solar system developed approximately 4.6 billion years ago out of a large interstellar cloud of dust and gas called a nebula. This theory depends on two laws of physics, which Dr. Hood, a physics teacher, will now explain.
What is Newton's law of gravity?
Okay, so Newton hypothesized that when there's two masses, they're attracted to one another. And the force of attraction is proportional to the product of the two masses over the distance between them squared. And by proportional, it wasn't until a couple hundred years later that this British dude Cavendish even came up with an experiment to determine the proportionality constant. But the law or the line of force is literally the line between them. And in Newton's other law, F equals ma, okay, the force is proportional to the mass. Actually, the force over the mass gives you the acceleration of one object to the other.
Newton's law of gravity was observed as the solar nebula fell inward due to an increase in gravity, often triggered by a star burning up its fuel and destroying itself in a colossal explosion known as a supernova. As the nebula collapses, it begins to rotate and heat up. As the radius of the nebula decreases further, its temperature continues to rise, causing it to rotate faster and faster. Another law of physics observed is the conservation of angular momentum. Angular momentum is the quantity of rotation of a body found by multiplying the object's moment of inertia and angular velocity. The scientific law of conservation of angular momentum states that in the absence of net torque, which is anything that can cause a change in an object's angular momentum, the total angular momentum of a system will remain constant. As the nebula continues to collapse, clumps of gas, dust, and ice collide and merge, and their random velocities average out into the nebula's direction of rotation, allowing the nebula to assume the shape of a disk, known as a protoplanetary disk. In the center of the nebula, the Sun formed, and the planets formed in the rest of the protoplanetary disk. This was due to the nebular material colliding and increasing in size. A great amount of the nebular material fell directly into the central mass that would become the Sun. The Sun contains 99.8% of mass in our solar system and has a diameter of roughly 1.4 million kilometers. To put this into perspective, about 1 million Earths could fit inside the Sun. The remainder of nebular matter collided into objects that began to orbit the Sun. As these objects grew larger, their gravitational forces increased, leading them to attract more matter and gradually build massive bodies that became the planets as we know them today. Our solar system is composed of 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Pluto used to be considered a planet, but was reduced to a dwarf planet. Of these planets, Jupiter is the largest, with a mass that is 300 times that of Earth. The matter that did not form the Sun or planets became the Moon, asteroids, and comets. The Nebular Theory is supported by the observation of disks around other stars which could be new planetary systems in formation. An example is Beta Pictoris, which is a young gas giant that has been uncovered to feature exoplanets orbiting the young debris disk A-type main sequence star. Scientists have uncovered 2 exoplanets orbiting so far and have been searching for more. Scientists must continue to explore in order to develop further knowledge and a deeper understanding of the nature of the universe.